Hello everyone, welcome back to the channel. So let's solve a problem today which is pretty much like IIT JEE level problem. It involves some physics and some mathematics and then some logical analysis and thinking to solve the questions and get to the solution. Okay, so let's read out the problem. A paraboloidal vessel. So paraboloidal is a parabola which is rotated about its axis by 360 degree. So you'll get a volume or a vessel. So that is paraboloidal vessel of height bigger h and radius big R is filled with liquid up to a height, let's say small h, as shown in the figure. H is less than bigger h. Find the maximum angular velocity omega. So this whole thing is being rotated about this axis, let's say y axis with omega. Let's say this is y and this is x. Of the vessel about its vertical axis y such that the liquid doesn't spill out. So doesn't spill out means liquid should maximum reach up to this point, right? The rim. Assume h equal to nh, okay, where n is less than 1. So all these things are given and we need to figure out what should be the maximum angular velocity of the vessel. So let's first figure out the equation for this parabola. So let's call this y1, and we know that we can write parabola equation as, let's say y1 as kx square, and we can do that if we assume this is origin. So we know that at x equal to 0, y is 0. So this is good enough. Now it is given that, let's say for bigger height h, the radius is r. So which means that h equal to k r square, right? We can simply put in this one. And let's say the initial radius is small r. So we can also write h equal to k r square. So using these two, we can have k equal to h by r square or also h small h by r square, which means that r square is h by h r square, and this ratio is given if you see here, which is n. So n r square. So we have two identities that we can write, h equal to nh, okay, and also r square equal to n capital R square. Okay, so far so good. We got the k and we got the first equation. So we can write first equation as, h by r square x square. Okay, let's go with this one. Okay, now what is the initial volume of liquid here? Because whatever happens, as long as liquid is not spilling out, then whatever happens, the volume of liquid will remain same. So let's calculate the initial volume, which let's say call it V0. And to calculate V0, in this case, let's say use at a distance x, let's have a small strip here, okay, of dx, right? And then height y. So the volume of this whole thing, because this is here as well, right? And it is circular, right? Like this. So it will be 2 pi x, right, into dx and into y, right? So this is 2 pi x and y is nothing but, let's say, kx square and dx. Therefore v0 is 2 pi k x4 by 4, and then this is going from 0 to r. So 2 pi k r4 by 4 or 1 by 2 pi, and k r square is nothing but initial h, so h and r square, right? So this is the initial volume. Or we can also write in terms of bigger or capital H and R as 2 half, h is nh, and this is nr square. So this will be half pi n square r square h, right? So this is the initial volume, right? V0. Let's call it question 1. Okay. By the way, you can also integrate this with by taking, let's say, a disk here of radius x and of height, let's say, dy, right? Okay, and so just to show you, this V0 will be pi x square, right, for this one, into dy. Okay, and you can write x square as y by k, right, dy. So this we can replace k with pi h by r square into y dy. So pi r square by h, pi square by 2, 0 to h. And this will be half pi r square h, right? So we can compute the volume like this also. Or you can simply just use the formula if you know, which is 1 by 2 pi r square h, right? So I think it's straightforward. Now let's move on. Now let's understand what happens when this is rotating. So let's consider this vessel once more. And at any moment when this is rotating with omega, so let's say it forms a curve like this, right? Because it will be swirling. Okay. So now let's say this is the situation at any given time. And for maximum omega, all we need to do is to know that the height of this curve maximum should not exceed the h, this point. And then it will not spill out. So let's consider a small part delta m here and see the forces that are acting on it. So one force is delta mg. Since it's rotating, so we can write delta m omega square x. Let's say if this is x, okay. And let's say the resultant of all these will be, let's say, r. Now imagine the tangent of this extending, and let's say that this makes an angle phi. Okay, so this is 90 minus phi, and this is also phi. Okay, so which means r cos phi is delta mg, and r sin phi is delta m omega square x. So therefore tan phi is omega square x by g, and this is also dy by dx, right, because this angle is phi. Okay, so therefore dy equal to omega square x by g dx, right? And if we integrate this equation, so we will get our second equation y2 for this curve. Okay, so let's have this curve as y2, and this curve we named it y1, which we have already computed here, right? Okay, so y2 is omega square any given radius x, x square by 2g plus some constant, let's say y0. Okay, and we don't know what is y0, but given the condition, let's say for x equal to r, okay, when the x reaches here, the maximum r, we know that y2 has to be h. So which means y0 is h minus omega square r square by 2g. Okay, so this is our y0. Now all we need to do is to compute the volume here, this volume, this volume, and equate with the equal initial volume that we had computed, because the volume is not going to change, right? So what is the volume here for this particular section? So we can again take a a small strip here at a distance, let's say x, right? And this is delta x, and this length is y2 minus y1. Okay, so the volume that we have now for this particular shape is 2 pi x dx y2 minus y1, right? Okay, so this curve minus this curve, right? Okay, so far so good. So let's just integrate these. Okay, so now what we get is, we just take the 2 pi outside, and x, and y2 is nothing but omega square x square by 2g plus y0, which is this h minus omega square r square by 2g, and minus y1, and y1 is h by r square x square, and dx, and this we integrate from 0 to capital R. Okay, so this is simple enough. Let's just integrate the equation. So 2 pi, this is omega square by 2g, and it will become x cube. So this is x4 by 4. This is hx, so h x square by 2 minus omega square r square by 2gx. So it will be integrated to x square by 2 minus h by r square, and this will be x4 by 4. Okay, and 0 to r. So let's just put the r in place of x. So this will become omega square r4 by 8g plus h r square by 2 minus omega square r4 by 4g, and minus h r square by 4. Now this will get simplified. We can just combine these two. So this will become 2 pi omega square r4 by 8g minus plus h r square by 4. And we know that volume is constant, so this has to be equal to 1 by 2 pi n square r square h, as computed earlier. Okay, so this is also, we can just further write it like pi r square by 2 minus omega square r square by 2g, and here plus h, if we take out r square by 4 outside. Okay, so pi r square will just cancel out both the side, and so what we'll have is minus omega square r square by 2g plus h equal to n square h. Okay, which means omega square r square by 2g is equal to h1 minus n square. Okay, and finally omega square will be 2gh by r square 1 minus n square, and that should be the final expression. Okay, so this is the answer. I hope it was simple enough, and you must have enjoyed solving this question. So thank you very much. Thanks for watching this video. Please do subscribe to our channel, like this video, and share this with your friends. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.